So we'll finish here with a couple of theoretical applications, almost, of the connection between the mean and the standard deviation. Again, where we're talking about the empirical rule and Chebyshev's theorem. And these are very powerful, important results that we're only scratching the surface of here, and we'll see more of, especially with the empirical rule, later on when we spend more time on the normal distribution in chapter 5. But roughly, what the empirical rule says is for a bell-shaped distribution, for a normal distribution, we have that about 68% of data is within one standard deviation of the mean, about 95% of data is within 2 standard deviations, and about 99% of data is within 3 standard deviations of the mean. And that says a lot, but really to understand this is better to look at a picture where we can see that on this graph of a distribution, we have these kind of windows around the middle. And in each of these windows, we're catching more and more of the data set. That in that one wide window, x bar minus x to x bar plus x, we've got about 34% in each side by symmetry. Then going out to x bar minus 2 to x bar plus 2, we're getting a couple more in the teens percentages, and then we get a few more going all the way out to 3 standard deviations away, where because that distribution gets closer and closer to the axis, we get less and less, but we are getting closer and closer to getting meaningfully all of the data. Although those ideas are things that we're going to have to wait until we get to chapter 5 to further develop. Meanwhile, for Chebyshev's theorem, we have that at least 1 minus 1 over k squared percent, the proportion of the data within k standard deviations of the mean. So, for example, if we were to make k equal to 2, we could say that 1 minus 1 over 2 squared percent, as it were, of the data is within 2 standard deviations of the mean, or 75%. That is at least 75% of the data is within 2 standard deviations of the mean. And Chebyshev's theorem is more general. It fits to most distributions. But the empirical rule is a little bit stronger, even though it's a bit more specific, because it gives a tighter approximation, in a sense. We're going to finish here with an application of these in an example.